My name is Robin Grubel. I am the CEO of the Canine Census Foundation. And thank you for registering for class. Please feel free to reach out at any point if you have questions, concerns, or would really like me to cover something in this class that I haven't hit on yet. A little bit about myself. I have been training and handling search and rescue dogs for 20 years. I started in wilderness search and rescue work, now do FEMA work, and started FEMA work about 12 years ago. And in the last 2 years have also started training narcotics, explosives, and detection dogs that way as well. So the impetus for this class this is probably version number 3 of this class, because as a certifying official, I have spent hundreds of hours following teams around in the wilderness, some of them lost, some of them not, and watching odor movement and how the air currents and everything are really not only affecting how the dogs work, but are really baffling to some of the handlers on why their search strategy isn't working, or why their winds changed all of a sudden in the middle of their search problem. And they're not taking a little bit of a chance to look at the whole really big picture. So this class, unfortunately, we are going to spend the first session, which is today, talking physics and meteorology. I never thought that when I sat in a meteorology class in college, like light years ago, that I would actually need to pay attention, because it was going to affect how my odor moved for my dog. But it does. So that's kind of the impetus for this class. We're going to talk about different types of wind, heat exchange, and how that actually creates air movement, and recognizing the signs of stable versus unstable air. Next class, we're going to talk about turbulence, flow, and we're going to do a little bit of work with vehicles and watching some vehicle work. Where was I? So we're going to actually talk, the third week is, we have the illustrations that Canine Census has made for instructors and for private use. So we're going to actually go through those and talk about how that will affect, and you can read those in the environment. And then the fourth week is going to be how to set up problems and educational opportunities for your dog to teach them to work through these types of scent theory. So I realized that this first week is really science intensive, in the sense that, yes, we're talking a lot of physics, but one of the things that I really think is important for people to understand is the why, so that you can set up a really good problem for your dog to be able to teach them what they need to know. So now I have to. Okay, so this is what we really want our searches to look like. And this is how we wish that all of the air would flow. Your body indications of the dog, they're directly downwind from odor or source, or where your victim's hiding, right? And you have the perfect search plan, and you're following all of your little arrows to go directly in. Well, these are fun and motivational for all of us, including the dog. But in order to actually think about how odor moves in its environment, this is what it looks like. Odor is more of a plume instead of a cone. It's more fluid in its matter, in the way that it moves through the environment. And if you look at this picture of this really nice candle and the heat coming off of the candle, where it's a darker blue, those are more concentrations of odor that we have to teach the dogs to be able to work through. It's not a nice cone shaped. I wish it was. I have to start visually thinking about this in a color format so that I can help not only my dog work through the problems, but so that I can explain to people how they should think about the way that their dog is working through a scent pool. When we start thinking about how odor moves, we have to think of the big picture. So one of the things that most people do when they get to a search is they pick up their phone, they look at the phone, and it says, your winds are out of the northeast today. And I've stood and watched a whole bunch of people do their odor tests while they're standing in the middle of a road. And if you think about it, that road is actually a wind tunnel. So the reading that you're getting for your wind speed and direction may not actually be a representation of where you're at when you step into your area. So be conscious of that as you get ready to step out. We have a whole bunch of things affecting air movement and wind in our areas. Meteorology is the science that deals with atmosphere and especially weather and air conditions. So keep that in mind. So what your prevailing winds are may not be what your local winds are. It does affect our overall search area and rain fronts as they move in. So are you moving from a bright and sunny day to a cloudy day? Can also affect how and when your winds are moving. So that type of information will affect your search strategy. Most of us are assigned to search a particular area, so we don't get to necessarily choose where we enter the area, but being aware of that sort of thing does help when setting it up. Then we start looking at the small picture. Smaller pictures can go anywhere from, instead of all of North America or even to your state or even your county. And since I know I'm dealing with a whole bunch of people in Europe, your countries get smaller and smaller, or even your metropolitan area. You could even go down to your block, your backyard, and then certain parts of your backyard. So we go from the big meteorology part down to your microclimates, which are specific areas. And a lot of the reading I've done, they can consider microclimates down even to a square inch. So if you're looking at certain things like bodies of water, microclimates very much exist around bodies of water. You have microclimates around buildings in your urban areas. A lot of microclimates in urban areas definitely can depend on the types of buildings that are there. So you have brick buildings which feel different than steel buildings because they retain heat differently. Valleys are definitely microclimates. So this particular picture is of the Bridger Range their Bridger Range in Bozeman, Montana. And just for those of you who are not, I'm in Iowa. So this particular mountain range is probably a 3-day drive for me. And my terrain that I work in all of the time looks nowhere near like this. I live in Iowa. It's very flat with rolling hills. Searching in this would give me, I would be doing it. Other people can do it. So if you look at this, dense pine forests grow on the north-facing slopes, which are to the left side of the mountain ridges. South-facing slopes are grass. So there is enough difference even in your soil temperature and your moisture between the two sides of those mountains or those ridges to make a significant difference in the microclimates. And not only in the microclimates, but that also helps dictate the vegetation that grows there. And it also will significantly determine how air moves over those particular areas. So we have different types of winds that are driving our odor movement. We have general winds, which these are prevailing winds, which is the large meteorology that we just talked about. We have local winds, and we have slope winds. Well, all of these winds are results of temperature differences. The pressure gradients between the areas, and even as you go higher, the pressure gradient in that as well. Local winds, which is typically what we're dealing with when we're out searching with our dogs, are microclimates, and they are also caused by the temperature difference, such as your terrain, the type of vegetation, the surface that you're walking on, and time of day. Some of the ways that winds develop are convection from daytime heating, unequal heating and cooling of the temperature surfaces, and gravity. Because we all know that colder and air sinks, correct? So we're going to take a little foyer, about this long, I promise, into physics and understanding how physics and heat transfer affect our winds. So a very nice generic graphic that's talking about a couple of different ways, even though it's a person, that we have a heat exchange going on. So the ones that we're going to concentrate on are convection, conduction, and radiation. So when we start thinking about radiation, the sun shines down on us, heats us, unless you're in Iowa at the moment and expecting minus 14 degrees Celsius highs later this week. It's heating all of the things that you're seeing. And it's usually from striking the surface, and the heat can either be reflected or absorbed, right? Oops. Conduction, sun shines down, heats the ground, heats the asphalt, and you can actually, this is one of the things that happens when you have a pan on the stove, and it heats the pan, and then everything, even if the fire hasn't touched it, heats all the sort of things around it because the heat is emanating and it's conducting through various surfaces. It also actually conducts into the air. So as we think of this as radiation. As a hot pan warms and it's warming all of the air around it, I think of that as radiation. That's actually conduction, and that actually helps drive air movement and air exchange. I'll keep pressing the wrong button. So, and then we have convection, because we have convection and conduction oven, right? So a convection oven it transfers heat by the air currents. I also think of how a tub warms, especially if you swirl the water around in the tub, that you can get a nice warming of all of your water that way. And this type of heating causes air to rise in one spot and fall in another. It's what causes drafts in your house and also helps create your wind and your breezes. This is one of my favorite graphics that shows what happens when you have heat balance. Land surfaces become warmer than water surfaces during the daytime. As a result, A sea breeze begins to flow inland from over the water. The warm air rises and flows back out to the ocean or lake and drops, and it creates that type of a cycle. In the absence of strong general winds, so keep in mind this picture is on a nice calm day, um, that's when we get this particular type of cycle. The surface sea breeze begins at around mid-morning, strengthens during the day, and ends at around sunset. And so the bottom picture is at night, and land surfaces can cool more quickly than your ocean surfaces or than your lake surfaces, and it reverses. So one of the interesting things to think about, and I have this nice little graphic of the fire on there, is that helps us dictate when we are going to search shorelines versus searching further inland, and how close you have to make your passes when you're actually doing that type of search to make sure that you're searching everything you need to be searching. The land breezes, so the bottom picture, begins at about 2 o'clock or 2 to 3 hours after sunset, and then ends shortly after sunrise when the land starts warming up again because the sun rose and is starting to heat all of the land that's around whatever body of water that you are working. So common local winds. During cloudy and windy weather, local winds will be weaker or non-existent, right? Topography will continue to challenge the wind, and in this instance, air will tend to blow along a valley axis. So it's going to blow up or down a valley. And it may do that regardless of time of day, even if we're trying to think about when we should be working our ridges versus our valleys. So broad, shallow valleys will provide less channeling than deep, narrow ones, which makes sense. The other thing to think about when you start looking at a valley can also be in vegetation. So if you have a electrical line cut through a whole bunch of really tall trees, that could also serve to be a type of valley. A valley could be an alley of a bunch of buildings in an urban environment. So just because I'm using wilderness examples, please take a few minutes to look around when you're out training your dog and say, well, okay, that's not a mountain, but that alley could serve as a valley. Local winds prevail the most during clear weather. So we'll concentrate on those clear days instead of the rainy, cloudy days when everything tends to be somewhat still. So winds of a local origin are crucial when you're developing your search strategy or thinking about how to set up problems to train your dog to work out any type of scenting issues that they may have. Slope winds are what we are most familiar with, and it's why we search ridges during the day and valleys at night. In the United States, and I don't know if this is different than Europe, the usual thinking is that 10 o'clock you start searching ridges at about 10 o'clock in the morning, and then at about 4 o'clock in the afternoon you start searching valleys. If anybody wants to tell me that that's different in Europe, that'd be great, because I don't know. I've never searched in Europe, so I couldn't tell you. Upslope winds. This is one of the reasons that we search during the day or on tops of ridges, right? This is a very simplistic view of how it all works. And one of the things that I do want to tell you guys is I have noted, and when you get the slides, all of the places that I have gotten these pictures are appropriately cited. And most of these pictures are in black and white out of a wildland firefighting book or pamphlet. I have asked a graphic designer to colorize them for me so they have this pretty watercolor view. If you'd actually looked at them originally, it's all done in black and white, and it's actually quite boring. So this is what's called an upslope wind. This principle holds true whether you're working in the flatlands of Iowa that's got rolling hills and the occasional ravine, or if you're working in Colorado with really big peaks on mountains. So upslope winds begin right when the sun strikes the slope, east facing slopes right after daylight, and they increase until intensity and extent as long as the daylight continues. South and southwest slopes heat the most and have the strongest winds, which makes sense, right? South slopes hit their maximum wind speed right after midday, and the southwest facing slopes reach their peak wind speed in mid-afternoon. Valley winds, and remember these valley winds can also apply to your alleys. They're channeled, but are not the same as upslope winds, probably a little too anal, but this is the way that the wind moves. And during the day in mountain valleys and canyons, they tend to become warmer than the air at the same elevation over your adjacent plains or larger valleys. So what you can't see right off of these pictures is they're assuming that they're a valley or a plain right at the bottom of the valley. And what happens is as the mountainsides heat up, that wind slides up the mountain and it pulls the cooler air that's on the plains up the valley. So the difference between upslope and up valley is that the winds don't start in your up valley portion until almost all of the valley has warmed. This is usually in your middle or late afternoon, depending on the size of the valley. So winds reach their maximum in early afternoon and continue into the evening. Upslope and valley winds together vary considerably by terrain and current weather conditions. Slope and valley winds develop better under clear skies, and heating and cooling processes are more pronounced. So this is one of those interesting things that unless you, I don't know if you work a lot of mountain areas, I work a lot of ravines and tall tree stands. And whether or not you're hitting some of this particular type of information sometimes depends on where you're actually working your dog the most. This is one of my favorite graphics because the first time that I ever came really into contact with this, I was riding on the back of a motorcycle, and you'd start up at the top of the hill. You're in a t-shirt, you're okay. You go down the hill, at the bottom of the hill, you're like, oh my gosh, you need a hoodie, and then you go back up the hill. And so these are downslope winds. And so on clear nights, the Earth's surface cools by radiating out more heat than it receives, right? Because the sun's down. The air in contact with the cooling surface also cools, which is what we're getting by conduction, right? Becoming more dense and moving downhill. So it collects at the bottom of the valley, forcing the warm air out. This is one of the interesting things that happens when our dogs get caught in scent pools at the bottom of a ravine, because if you can see my pointer, especially if we're down here, our dog is hitting right here. It could come down here and it can get trapped because this is where odor pooling, when possibly our odor sitting up here. Now, one of the other interesting things is that definitely happens in here. If our dog hits here, it might be able to get odor here, especially if our odor source is laying here. This is an easier way for our dog to figure out than in the previous slide. So think about that as you're setting up your search problems. So upslope and downslope winds can occur at the same time, depending on which side of the valley is getting heated. And as the sun moves over, they can reverse because you now have the western slope getting heated instead of the eastern slopes for getting heated. So this is interesting because that is what leads you to an undulating flow throughout a valley or a range of hills. And this is one of the reasons why we can have our dog hit on something that's 2 hills over, but we would have to continue to go out of odor and back into odor and out of odor and back into odor to be able to help the dog get to the point where it needs to be so that it can actually find source. So we're going to take a few minutes. Oh, here's slope winds at night. It all pools in the valley. And the transition from up valley, so when all of the wind was going up, to down valley flow takes place early in the evening when everything is starting to cool. The transition is gradual. First downslope winds, then pooling of cool and heavy air in the valley bottoms. So in the United States, we tend to do a lot of searching at night for live subjects. We don't do that typically for cadaver work. So very important for our live find handlers to know. In this particular graphic, what looks like water in this graphic is actually cool air. So, but many times if you start thinking about how odor moves as a liquid instead of a gas, for me, that actually helps a lot to think about where odor is going to catch, where it might pool, how I need to teach the dog to actually work it out. Water will flow down topographic channels, but air movement will be guided by them, but can also do some funky things if it hits restrictions. Next class, I'll show you some awesome graphics around turbulence. So you can actually have a visual representation about how your odor may flow as you start hitting things like tree lines, vehicles, bushes, everything else where you can't have straight line winds, right? So now we're going to talk about atmospheric stability and how to recognize that, because what we have been talking about a lot is what happens when it's stable. This is the indicator of stable air. Clouds are in layer, it's foggy, no vertical motion. They're stratus type of clouds, and smoke columns tend to drift apart. They don't go straight up. And you have steady winds, so steady light winds. So as you're looking, especially at the top picture, Imagine what would happen if your subject or your odor source was underneath one of those particular trees. There would be like this big, huge billow of odor, and that billow of odor would slowly be migrating across that particular rise. Being able to recognize this type of meteorology and wind patterns is key, because it will help you determine how wide your swaths have to be for setting your grids to cover your search area, which actually then leads into how good your probability of detection is. It also will be able to help you tell incident command what is and is not been covered or has not been covered. So here's unstable air. Winds tend to be turbulent and gusty when this happens. You can see that the clouds are more going upright instead of low and slow out. This really reminds me of that very first picture that we had of the candle giving off that heat source, right? There's lots of clumping. It's not very even. The dogs might run out of odor when they run into odor before they run into odor, or it's not that beautiful, pretty comb, right? And so indicators of unstable air are cumulus types of clouds. If you guys want to go do a little bit of research, I had a whole slew of slides that talked about, well, here are the clouds that you get when you have stable air, and here are clouds that you have when you have unstable air. But pretty sure you all know how to run YouTube, and you can find those. On the end of this particular set of slides, I actually have included a couple of YouTube links to some videos that, as I was doing my homework, I found either really interesting or would provide some additional supplemental information for you. You have really good visibility during this time when you have unstable air, and you can also have dust swirls. Now, one of the things that I did do is can everybody see this? I have a YouTube. I'm going to play this little video for you. It's only a minute 13.
Clouds are a familiar sight in the skies over our heads. They can grow and turn into showers or even thunderstorms. We just need the right conditions in the atmosphere, something that we call instability. But it can also be thought of as the buoyancy of the atmosphere. Now, we can show you that using water at different temperatures. In this plastic beaker, we have cold water. I'm going to lower some warm water that's been dyed red in this old spice jar. And let's just see what happens. As we lower that down to the bottom, notice the red starts to rise out of that spice jar. The warmer, less dense water rising around the colder, more dense water. And that's convection in action. That's what happens in our atmosphere. The air rises, and as it cools, it condenses and forms cumulus clouds. It's also what happens with thermals. When on a hot day, the ground heats up, that warms the lower part of the atmosphere, and that warmer air rises because it's less dense. Those thermals that we see used by birds and gliders and even hot air balloons.
All right. So stability in the lower layers, which tends to be a lot of what we think about when we're out searching. Steady surface wind, nice calm wind. Gusty winds, when you have a new front coming in, that's unstable air. Dust devils, that's what we call them in the United States, where they're the little tiny tornadoes that appear on the ground. I don't know if you guys call them something different. Are indicators of instability near the surface. Haze and smoke are stable air. And as things go up into the air, that is unstable air. So I have left about 20 minutes for questions, or if there are no questions, I'll give you 20 minutes back. So what's going to happen next week? We're going to talk about flow. We're going to talk about turbulent winds. And we're also going to go over a couple of different examples. I have videos of smoke bombs in vehicles. So we're going to look at a couple of those as well. And that will be next week. I would greatly appreciate any questions. If you have anything for this week, or if you have anything specifically that you want me to cover next week, that would be great. And just so you guys know what you're going to get when you get the PowerPoint slides, here's going to, I'll have some links. I might throw a couple more on there while I'm looking at stuff for next week. So what questions do you guys have? Do you have any from this week?
Hey Robin, can you hear me? It's Rory here. I got a little bit lost, I have to admit, in the up valley upslope, down valley downslope bit. I don't know if you'd be able to just, in a complete idiot's guide, run through that again.
Sure. You know what? I'm all about pictures, right? So is this what you're talking with the valley slope winds, the upslope and downslopes?
And I think the two before that as well.
This one or that one?
Yeah, that's the one.
That one. Okay. See, and you guys think that I have this all figured out. I so have notes. Because one of the things that I realized as I was putting together this class, you put me out in the field with the dog, and I'm pretty good about reading it. But when you want me to sit down and explain it to you in a classroom setting, it freaks me out a little bit. So when we start talking about upslope and valley winds, the velocity, the winds and the slope are determined a lot by terrain and current weather conditions. Okay, so almost everything we talked about develops under clear, stable conditions. So also, this is the perfect day that you want to be out searching with your dog, because the wind is doing what it's supposed to be doing, not what it imaginarily makes up when you have a changing of the season. So upslope winds, which are upslope winds. Remember, this is these guys. They're really shallow down here. And as you go up here, they get wider, right? So they might be at your knees down here, and by the time you're up here, it's over your head. So it expands as you go up the side of the mountain. Valley winds. So think about this. This is your upslope wind. This is your morning upslope wind. So your winds are now going straight up the side of the mountain. But let's talk about figure 3, which is an afternoon canyon wind, because not only is the wind, upslope winds happening, but you also, because of the heating of the earth or the ground, it is pulling the warm air off of the cooler plains that are below it. So it's sucking up the wind up the valley. You have an upslope and a valley. So instead of going straight up the sides of the valley, it's now actually pulling and going more at a diagonal. Does that help?
Yeah, that helps. So it's almost like there are two two slopes being heated in action. So in the morning, you've just got the slope going up the sides, and then because the valley rises, you've got that increase in gradient plus the slopes on the side that makes it go up diagonally. Does that sound about right?
Yes, that's excellent. Yes.
Cool, thank you.
Okay, so Belinda asked, once our dog is trained in search and rescue, how can I become a part of a search and rescue team? Yes, it's perfectly okay to ask that question. Belinda, you need to get a hold of me. Are you in Europe or are you in the United States? That's going to be a big question because I can answer that question. Oh, you're in the US. Send me a private message like over Facebook or an email, and I can help plug you in. And we should get you with a search and rescue team before you do too much training so that we can make sure that you're getting the type of training you need for your area of the United States. Other questions?
Oops. Hello?
Yes.
Hey, well, it's not really a question, but just to let you know that I mostly do urban stuff. So I definitely appreciated your comment earlier on how, everything applies also to buildings and alleys. So just in the back of your head, if you have any other of those little notes, I'm definitely listening for that.
Perfect. Well, and here's the other thing that I want you to start noticing with your urban, as I talked about the different types of buildings, but also notice how the different type of pavement makes a difference. Because your asphalt will heat differently than your concrete, which will heat differently than gravel, which will heat differently than dirt. So you have all of that terrain. When I start talking terrain, that's the type of terrain that I'm talking about. And
awesome.
Right, so that conducts and makes heat exchange different as you're moving through. That what your buildings are made out of. In the where I live, we have a lot of brick buildings, and they're the red brick. Well, if you go up at 10 o'clock on a warm day and put your hand on a red brick building, there will be a distinct temperature difference between it and the limestone building that's right next to it, or the building that's got siding. And so all of those things, and now I'm talking microclimate stuff. So this is itty bitty stuff. But when you start thinking, even as a trailing dog handler, how those services can affect how your air moves and your scent moves across that pavement. And is it going to stick or is it going to rise when it hits a brick building or a limestone building or a building with siding on it?
Awesome. Thank you.
Yeah. Okay. Because I'm like, it's kind of funny because I'm trying to give you guys an idea of what goes through my head, because God knows you don't want to live there. When I'm watching a dog work, and I'm watching a dog work an odor problem and understanding what tendrils of odor it is trying to pick up and how that tendril of odor got there based on where I placed odor or where I know that person is or that person walked. And one of the best ways you can absolutely teach yourself about scent theory is go in, study a building or an area, think about where you would set up or put odor in order to accomplish a specific task or scent theory concept to train your dog. Set it up and watch 10 different dogs work that scent problem. I did not learn all of this stuff by reading a book. I learned all of this stuff by setting up hundreds of problems in large open areas, in buildings, in small areas for trailing dogs, for cadaver dogs, for area search dogs, for disaster dogs, and watching them work air movement. And so as much as you can do that and get those 1,000-hour eyes, being able to watch hundreds of dogs or thousands of dogs do it, I strongly encourage you to do that. Sorry, that was a rant.
That's super good advice. Thanks.
It was a little bit of a rant, but that's okay. Other questions? Feel free to text me, be like, hey, next week, can you do a short refresher on XYZ? Or really cover this, that'd be awesome. I would be happy to do that. Otherwise,